I'd like to try and connect this to biodiversity issues, and to do so in the following way. I think there are three pieces to this that are unsustainable. One of them is the use of fossil fuels. And then if you go back to the classic paper that Paul and Anne did with back in 1985, looking at how much primary productivity we use, there's two big pieces of that which are unsustainable. One of them is our use of forests, and forest cover is shrinking. And then the other is broadly the desertification of rangelands. I thought when I looked at those data that the UN data were absolutely appallingly bad, that the FAO couldn't be trusted to even define a tree. But with the work that's coming out of Maryland from Joe Sexton's group and others, we now have very, very good data on forests, which are really important for biodiversity because 2/3 of all species there. We're still not in a very good way to assess changes in rangelands. And I wonder to the extent, how are you incorporating the new and really quite good data on forests? And then how are you trying to get at the rangeland issues? With Gretchen, I'm involved in the same team in China I'm getting a handle on the desertification there, which is getting better, but there's an awful lot of other places. So I wonder if you can comment on those drivers that connect specifically to biodiversity.
Okay. Yes? Okay. Thank you, Stuart. I'm so glad you're asking this question. So we see ourselves as data aggregators. So we just aggregate the data. And we chose strategically just to focus on UN data because we understand all these limitations. But just to say, we can show you how you can aggregate the data if you really want. And if you want to have better understanding, it's the responsibility of each nation to provide better data. We believe, therefore, our assessments is most likely strongly biased towards underestimating overuse for a number of reasons we could go into. And still we can show quite significant overuse and resource tightness. So I think we try to err on the side of academic defensibility rather than human survival. So that's kind of our choice in terms of choosing the data. But there's much better data available. I understand. I wonder why the UN is not picking it up, but that's a distinct problem, yeah.
Really, it's unbelievable that Swiss is in this situation that you say, because we think that Swiss use all things, and the terrace, very nice, and these things. But I think if you put also in the natural part of capital the use of the transgenic food, I think that the capability can have a different measure. This is my question. You put in the natural capacity the use of this new technology, because if in Swiss I think not use this, and this is a problem for the European countries. So my question is, when you speak about the natural capital, you put also the new technologies or not?
What we do is we are ecological accountants.
The other thing is you don't speak about Argentina.
That's a big mistake. I'm sorry about that. Yeah. So. Yeah, no, it's great. So, as I tried to say, we are ecological accountants, so we look backwards. We're like driving a car looking at the backward mirror in some ways. But accounting has an important function also in companies, just to understand what's going on. So we look every year what's going on. If we change technology every year, then the ratio becomes different because of all the factors that go into the calculation. Now, we could speculate about Switzerland, what the potential would be if they had higher yield productivity. Actually, in Italy, the ratio ratio between demand and regeneration in Italy is also about 4:1 in Italy. In Switzerland, a big part is fossil fuel use, so a big part of that could be squeezed out by using renewables and photovoltaics, etc., so that's possible. On the food side, Switzerland imports about half of the food. I think the Swiss productivity is relatively on the high end, so I'm not sure how much it could be boosted. Probably it could be boosted some. It's quite interesting that in Japan, for example, which has very high yields, I was surprised to see that the yields in Japan over the last 40 years dropped by about 25%. And the reason is that they were very much pushing their own food security earlier, so they pushed their systems very hard with very detrimental effect on water pollution, and so they have kind of chosen to have lower productivity and better environmental quality. So I don't know how much it could be boosted. I think there's a lot of potential. The first question to me is, for Switzerland more, is it a risk or not to have a footprint that is so high compared to their own biocapacity? And what surprises me is that the competitiveness plan of Switzerland does not include resource security. There's a little bit of a deposit of fossil fuel that lasts 4 months in Switzerland, but I think the 21st century has more than 4 months. So I'm not sure exactly about that plan. Yeah. Or also to say, like, you go to the World Economic Forum, they produce a report called the Competitiveness Report. 114 indicators, not one of them is about climate change, energy provision, water, anything about environment. It's about how far people fly and whether they have good degrees, and etc., which is important, but doesn't look at the whole picture.
Well, thank you very much. Matthew, I speak as an admirer of this work because I've used it, as you know. And the paper with Paul, this second half of the paper, we made some use of your 1.6 to translate it into economic terms. But this is, I speak as a fan, now for the criticism. I think the idea of going for ecological footprint is just right. You've got the conceptual model of the entire biosphere as a gigantic renewable natural resource, and it has a flow of goods and services to maintain itself, plus you can take something out of it, and the question is how much are you taking out? That's the supply and demand. But when it comes to an economic system of economic statistics that has been created over the past 65 to 70 years, at every stage we have made errors, systematic errors, because we have been neglecting. So we are now paying the price of estimates, and I speak to the global, the World Bank ones, which have been polluted through missing out a crucial aspect of it. So I would be very ginger. A light touch is required for so bold a research program as you do, rather than squeeze as much as you are doing in this paper. So let me give you an example. If you can go back to the table in which you narrated the breakdown of wealth of nations, or the aggregate from the World Bank, you will find that the share of wealth to natural capital was 5%. Now that's very, very close to the share of GDP in agriculture. And you can see now why that's way off. So your research strategy of making conservative estimates and then showing a bias is exactly right. Couldn't agree with you more. I mean, that's the right strategy. But on the other hand, you're squeezing more than simply saying, look, we're overdoing it, or we have overshot it, 1.6 or 1.5. That's not the point. The real point is that it's not 1, and it's above 1. You don't want to go to a second place of decimal. It shouldn't be 1.64. Drop the 4. Stick to the 1.6. But the light touch is what's not needed, because the conceptual model is exactly right, in my judgment. It's when you squeeze numbers out of it and go into greater and greater detail that serious problems can arise given the fact that the basis of these numbers are coming from the UN or World Bank. And as you can see, the 5% immediately shows what errors have been creeping in. So keep a light touch. These are early days for this work, but it's a terrific idea. That's the right way to go about it, I think.
So if I'm looking at your slides correctly and also drawing on Tim's closing comments from yesterday, it really is the need for soaking up carbon that's driving a lot of this overshoot. And for those reasons, there's a lot of people saying maybe we can't use the biosphere to soak up carbon. And while I'm not normally a technological optimist, unlike others, there are people developing, including people at ASU, special materials and resins that are non-biological to soak up carbon that are easily deployed in small scale. So how does this picture change if we don't need to use the biosphere to soak up carbon? How many nations switch from that ecological deficit to ecological surplus? Because it seems to me quite a few would, which would explain why we're still here, by the way, given that we're overshooting by a pretty large factor.
So it's true, like if magically we could just make all the CO2 go away or have CO2-free energy at no cost from today to tomorrow, our use according to our estimates, which I think are underestimates because they don't include water depletion or soil depletion at this point, because there's no data available enough to really put that in, we would be about 60% of the biocapacity of the world, or a bit more. And that wouldn't meet with E.O. Wilson's standard, but it would be a much better situation. But we also see, I mean, for example, Denmark tried to decarbonize its electric production by adding 10% of biomass from the United States to its coal plants. So the Dutch try to do that as well. So if we really try to fire our coal plants with biomass, then it's going to be a shift onto other ecosystems. So it's possible to move out of carbon, and it's possible to do it without destroying the rest of the planet, but there's also pathways that would do a great detriment to the rest of the planet.
Fair enough. But
so by having a framework, you can actually then see which options are helpful and which ones are not.
That was splendid, Matthias. Thank you so much.